Good day. Again, I am Sir Hernando Roldan, and in today's video, I am going to share to you the horizontal and vertical asymptote of rational functions. Okay, so let us first define an asymptote. An asymptote is an imaginary line to which a graph gets closer and closer as the x or y increases or decreases its value without limit. So there are different kinds of asymptote. We have the vertical asymptote, which is the vertical line x equals a is a vertical asymptote of a function f if the graph increases or decreases without bound as the x values approach a from left or right. The vertical asymptote of the rational function is the zero or the zeros of the denominator but not the numerator. The second kind of function or asymptote is the horizontal asymptote. The horizontal asymptote is the horizontal line y equals b is a horizontal asymptote of the function f if f of x gets closer to b as x increases or decreases without bounds. There are different determining factors in determining the horizontal asymptotes. Such conditions are as follows. To determine the horizontal asymptote of a rational function, compare the degree of the numerator n and the degree of the denominator d. If the degree of the numerator n is less than the degree of the denominator d, the horizontal asymptote is y equals 0. If n is equal to d, or if the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote y is the ratio of the leading coefficient of the numerator a to the leading coefficient of the denominator b, that is y equals a over b. And if n or the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Okay, let's have these examples. Determine the vertical asymptote of the following rational functions. F of x is equal to x minus 2 over x plus 3. So let us determine the vertical asymptote. So as we have said earlier, the vertical asymptote of the rational function is the zeros of the denominator but not the numerator. Okay, so let us find the vertical asymptote of f of x equals x minus 2 over x plus 3. So we are going to focus our attention to the 0 or zeros in the denominator. When we say zeros, we are going to equate the denominator of the function to 0 to determine its vertical asymptote. And therefore, we have x plus 3 is equal to 0. So transposing 3 to the right side of the equation, x is equal to negative 3. So we transpose positive 3 to the right, it becomes negative 3. And therefore, negative 3 is the vertical asymptote of the given function. Okay. Another g of x is equal to x minus 1 over x minus 3 times x plus 4. So again, we will focus our attention only to the denominators or denominator of the function. So first, we are going to equate the denominator. Since the denominators are already factored or already prime, we are going to equate it to 0 so that x minus 3 times x plus 4 equals 0. Equating the factors to 0, so you have x minus 3 is equal to 0, then x is equal to 3. Equating x plus 4 to 0, so we have x plus 4 to 0, and therefore x is equal to negative 4. So what are the vertical asymptotes of the given function? So we have 3 or positive 3 and negative 4 are the vertical asymptote. Next, number 3, find the vertical asymptote for g of x equals 2x squared minus x plus 1 over x squared minus 5x plus 6. Okay, so since the both the numerator and denominator are quadratic, we are going to factor this quadratic functions. Factoring both the numerator and denominator, we have 2x plus 1 and x minus 1. So 2x and x are the factors of 2x squared. Then the factors of 1 are 1 and negative 1. So for the denominator, the factors of x squared, we have x times x or x and x, and factors of 6 whose sum is negative 5 are negative 3 and negative 2. Okay, so since the denominator and the numerators are factored already, let us equate the denominator to 0. So that x minus 3 times x minus 2 equals 0. Equating each factors to 0, x minus 3 equals 0. Therefore, x is equal to 3. Equating x minus 2 to 0, or x minus 2 equals 0, then x is equal to 2. So what are the vertical asymptote? The vertical asymptotes are 3 and 2. Okay. All right. So these are the ways on how can we find the vertical asymptote of the rational function. Okay, next. Determine the horizontal asymptote of the following rational functions. F of x equals 3x plus 8 over x squared plus 1. Let us find or determine first the degree of the numerator and the degree of the denominator. The degree of the numerator is the leading exponent of the terms in the expression. So for the numerator, the degree of the numerator of the given function is equal to 1, since the highest exponent is 1. And the degree of the denominator is equal to 2, since the highest exponent is equal to 2. Finding the relationship between the degree of the numerator and the denominator, we have the degree of the numerator is less than the degree of the denominator. In this case, what is our horizontal asymptote? So since n, or the degree of the numerator, is less than the degree of the denominator, then the horizontal asymptote is y equals 0. Okay. So y equals 0 is the degree of or the horizontal asymptote. Next, g of x equals 3 plus 8x squared over x squared plus 1. Let us determine first the degree of the numerator. What is the highest exponent in the numerator? We have 2 as the highest exponent. Therefore, the degree of the numerator is equal to 2. So what is the highest exponent in the denominator? We have 2. And therefore, the degree of the denominator is equal to 2. Let us find the relationship between the degree of the numerator and the degree of the denominator. So in this case, n is equal to d, or the degree of the numerator is equal to the degree of the denominator. So since n is equal to d, then the horizontal asymptote is equal to y equals 8 over 1, or 8. So 8 is the leading coefficient of the numerator, while 1 here is the leading coefficient in the denominator. So that y is equal to 8 over 1. So 8 divided by 1 is equal to 8. Therefore, the horizontal asymptote, or yes, the horizontal asymptote of the given function is at y equals 8. Okay. Next. Number 3, g of x equals 8x cubed minus 1 over 1 minus x squared. Let us now determine first the degree of the numerator. What is the highest exponent of the term in the numerator? So the highest exponent of the term is 3, and therefore the degree of the numerator is equal to 3. So what is the highest exponent of the term in the denominator? The highest exponent is 2, and therefore the degree of the denominator is equal to 2. So let us find the relationship between the degree of the numerator and the degree of the denominator. The degree of the numerator is greater than the degree of the denominator. In that case, since the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote for the given function. Okay, so that is how are we going to determine the horizontal asymptote of the rational function. Okay, so thank you for watching. I hope you learned something from this video.